In question 4, we have a small polystyrene ball suspended between two vertical metal plates, P1 and P2, 80 mm apart, initially uncharged. The ball has a charge of minus 0.17 microcoulombs. In A part 1, a potential difference of 600 volts is applied between the plates when the switch is closed. We need to find the magnitude of the electric field between the plates, assuming it is uniform. Well, electric field strength is potential difference over distance, which in this case is 600 volts over 80 millimeters, giving an electric field of 7,500 volts per meter. In part 2, we need to show that the magnitude of the electrostatic force acting on the ball is 1.3 millinewtons. Well, force is given by electric field strength times charge, putting in the value found previously, and the charge of 0.17 microcoulombs gives a force of 1.28 times 10 to the minus 3 newtons, which is around 1.3 millinewtons. In B, we're told the ball is displaced from its original position, coming to rest when the suspended thread makes an angle theta with the vertical, as shown here. In part 1, we need to mark and label the forces acting on the ball in this position. Well, it has the weight acting down, the electrostatic force acting to the left, and the tension in the string. In part 2, we're told the mass of the ball is 4.8 times 10 to the minus 4 kilograms, and by considering the equilibrium of the ball, we need to find the value of theta. Well, the tension times the sine of theta gives the component to the right, and this must equal the electrostatic force, EQ, that we found previously. Tension times the cosine of theta gives the component of the tension acting up, which is balancing the weight, mg. Putting these together, and then sine theta over cos theta equals tan theta, the tension now cancels, and so tan theta equals the electrostatic force divided by the mass of the ball and the acceleration due to gravity, coming out at 0.272, giving theta at 15.2 degrees.